In this lesson, you're going to learn how to graph quadratic equations. These are the parabola-shaped graphs. And what we're going to do is we're going to work through all these different forms of the quadratic equation here to graph these parabolas in these different forms. So we've got the vertex form, the intercept form, the standard form, and then some of the parent function graphs. We're also going to talk about transformations, and we're going to talk about how to approach these graphs so you can easily get a good graph. So let's dive in. The first problem is just to basically look at the y equals x squared form of the equation, and this is what we call our parent function. What you can do is you can just pick some points. I usually pick a couple negative, 0, and a couple positive, and we're just going to put those in for x. So we've got negative 3 squared, which is 9, negative 2 squared, which is 4, negative 1 squared, which is 1, 0 squared is 0, 1 squared is 1 times 1, which is 1, 2 squared is 2 times 2, which is 4, and 3 squared is 9. Now let's go ahead and plot these points. We've got negative 3, 9, which is way up here, so I'm going to skip that one. Negative 2, 4, which is right here. Negative 1, 1, which is here, 0, 0, 1, 1, 2, 4, 3, 9. But when you graph this, you get this nice like U-shaped graph, okay, and that's what we call a parabola. Now what happens when you have, like for number 2, we have y equals 2x squared. What do you think that 2 does to the graph? Well, see this is the form we're working with now. The a value, if it's greater than 1, it stretches the graph. And if it's between 0 and 1, it shrinks the graph. Okay, it's a vertical shrink, like a compression. And if it's negative, what it does is it reflects it over the x-axis. It's going to make it open down. Okay, and we're going to look at all those different types now. So let's go ahead and look at y equals 2x squared. Again, you can make a table. Sometimes what students make a mistake is they think about working from left to right. You want to think of doing the order of operations, the PEMDAS. So if we put negative 2 in here and we square it, negative 2 squared is negative 2 times negative 2, which is 4, times this 2 here, which gives us 8. Negative 1 squared is 1, times 2 is 2, 0 squared is 0, times 2 is 0, 1 squared is 1, times 2 is 2, and 2 squared is 4, times 2 is 8. Now one thing that you'll probably notice is that, see how these values here are the same, these values here are the same, and that's because the graph is symmetric about this axis of symmetry. Now when we talk about axis of symmetry, it's this vertical line, okay, that divides the parabola in half. In this parent function, that line is the line x equals 0. Remember, x equals lines are vertical lines, whereas y equals lines are the horizontal lines. The other thing I want to talk about, and this is something that sometimes when I'm working with students, tutoring students, you know, their teachers give them all different like little techniques, and you might find this helpful. When this a value is positive, you can think about it, when you're positive, what do? You smile, right? So you can think of a as positive, that opens up, see that smile? There we go. Whereas if you think about being negative, right? Say if the a value is negative, opening down. See how this is kind of like a frown, okay? Opening down. So you could use that as a way of kind of remembering if that helps you. But let's go ahead and plot these points. I'm going to switch colors here. Let's go to green, and we've got, let's see, negative 2, 8, which is way up here. We've got negative 1, 2, which is right here. 0, 0, which is here, 1, 2, which is here, and 2, 8, which is way up here. So when you look at this graph, what do you notice? Well, the 2, okay, that a value is greater than 1, so it's a vertical stretch, which means that the graph is going up faster. Some people refer to this as being narrower, but I just like to think of it as a vertical stretch, like you're pulling it up vertically, and that's why it's, you know, like narrower like that. The other thing that comes up when you're doing these problems is domain and range. So when you think about domain, you think about what can the x values be. So I usually look from left to right. And when you think about the range, you think about what can the y values be. So I kind of think from low to high. With these parabolas that we're going to be working with in this video, the domain is always going to be all real numbers. So that means that x can go all the way to negative infinity, all the way to positive infinity. But when we look at the range, okay, the y values, you can see y is not negative over here. It is equal to 0, it just touches right at the x-axis, and it's above the x-axis, so we say that the range is y is greater than or equal to 0. If you're using the interval notation, as you go on in math, it's going to be looking something like this, where it's equal to 0 all the way up to positive infinity. It can never reach infinity. That's an open interval here on the right. So we're going to work with inequalities though for this video. So let's go to number 3 now. What do you think happens here with y equals 1/2 x squared? Well, if you said that the 1/2 is going to be a vertical shrink, you're absolutely right. And that's, again, it's because this a value here is between 0 and 1. So when it's less than 1 like that, but it's still positive, you know it's going to be a vertical shrink. We're going to talk about negative next. So let's go ahead and plot some points here. So if we've got -2, let's see, -2 squared is 4, times 1/2 is 2, -1 squared is 1, times 1/2 is 1/2, 0 squared is 0, times 1/2 is 0, and then these are going to be the same. Okay, see how it's symmetric, it's the same on both sides. So let's plot that on the same graph so we can see what this looks like. -2, 2, -1, 1/2, 0, 0, 1, 1/2, and 2, 2. So here, you see the red graph? This is a vertical shrink. So what happened was it actually made the graph wider. See, the black one was the original one, the red one is the new one, and it's just a vertical shrink. You're compressing it, making it wider. The domain and the range are exactly the same. So these are just, when you're talking about the a value, you're talking about the vertical stretch or shrink, or in number 4, where you see that it's negative the a value, then it's going to be a reflection over the x-axis, and it's going to open downward. Just like we said, when this a value is negative, it's kind of like when a person's negative, they're frowning, okay, it's going to be opening downward. So let's plot a few values here. We're going to get into some more difficult ones here in just a minute, but I just want to lay the foundation here for you so you kind of know, how these all work, just working with the parent function. So we've got -2 squared, which is 4. Now remember, some people think negative times a negative, well, isn't that a positive, Mario? Well, remember, you want to do the exponents first. So -2 squared is 4, times a negative is going to give us a -4. -1 squared is 1, times a negative gives us -1. 0 squared is 0, times a negative is still 0, and then we're getting the same, -1, -4. So if we plot those, -2, -4, -1, -1, 0, 0, 1, -1, and 2, -4, what you'll notice is that it has the same shape as the original graph, the y equals x squared, the parent function, okay, same shape. It's just been reflected over the x-axis, okay. All right, so let's dive into some of the ones that involve ax squared plus c next. Now, what do you think that c value does to the graph? Well, let's take a look in number 5. So I'm going to make a table. I'm going to pick, like I did before, just some small numbers, a couple negative and a couple positive, and let's take a look. So I put -2 in. -2 squared is 4, plus 3 is 7. -1 squared is 1, plus 3 is 4. 0 squared is 0, plus 3 is 3. 1 squared is 1, plus 3 is 4. And 2 squared is 4, plus 3 is 7. Let's go ahead and plot these. We've got -2, 7. 1, 2, 3, 4, 5, 6, 7, right about there. -1, 4, right about there. 0, 3, 1, 4, and 2, 7. So there's our graph. And notice this 3, see how it crosses the y-axis right at 3? So what this did here, the 3, the c value, picked up the graph and it moved it up 3. So that's what we call a translation or a slide or a shift. Usually translation is probably the more proper term, is shifting up 3 units. Now, if you look at this, y equals x squared, that's our basic parent function that we talked about in the very first problem. We just picked it up and moved it up 3. So that's for number 5. Number 6 now, what do you think happens here? Y equals x squared minus 2. Well, you're probably saying, Mario, I see that y equals x squared again, but that minus 2 is going to shift down 2, right? So what you can do is you can make a table again, but if you're starting to catch on to the pattern here, you can say, well, I know this just shifts down 2. Why don't I just pretend like -2 here is my new origin, my new starting point? Then I could make a table just using my parent function y equals x squared and plot from here. So let's go ahead and do that. So this would be -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. It's just that I'm going to plot these points from here now. So I'm going left 2, up 4, left 1, up 1, 0, 0, right 1, up 1, and right 2, up 4. Now you don't have to do it this way. If you don't feel comfortable, you can use the whole equation. But just remember, when you use the whole equation, you want to plot from the 0, 0 point, that origin. If you just use the y equals ax squared part of the equation, then you can graph from that shifted origin, okay, up or down. Okay, let's look at number 7. Now we're putting together this a value 3 with this c value 1. So what do you think happens here in this problem? Well, The 3 is going to be a vertical stretch. And we know that when it's a stretch like that, it's going to make the graph look narrower because it's going up faster, right? But the +1 is going to shift it up 1. Okay, so again, you can use the whole equation if you want, or you can do the little shortcut that I was showing. You could just use the y equals 3x squared and plot from here, up 1. Either way, you're going to get the same graph. So I'm going to use the whole equation this time. So I'm just going to put in -2, -1, 0, 1, and 2. Remember the order of operations. -2 squared is 4, times 3 is 12, plus 1 is 13. -1 is, -1 squared is 1, times 3 is 3, plus 1 is 4. 0 is going to give you 0 squared, times 3 is 0, plus 1 is 1. And then it's going to be the same on the other side because it's symmetric about this axis of symmetry. Now, sometimes what you can do when you draw this, you can draw it as kind of like a dashed or dotted line, that axis of symmetry. So far, all the problems we've worked with, that axis of symmetry is x equals 0, right on the y-axis there. If you fold it over that line, it's going to match to itself. The graph is going to pair up like that. So now let's go ahead and graph this. So we've got -2, 13, that's way off the graph, -1, 4, which is right here, 0, 1, 1, 4, 2, 13. Now you're probably saying, Mario, why is it going way off the graph like that? Well, because remember, the 3 is stretching it, right? So the further you go out, it's going to go up really fast, right? Now, the one thing we haven't talked about yet is the maximum and the minimum. So what does that mean, maximum and minimum? Well, when the a value is positive, remember positive smiling, it's opening up like this, you actually have a minimum, a low point, but you don't have a maximum. See how it keeps going up to infinity forever and ever? So when it opens up, a is positive, you have a minimum. And what is the minimum value? Meaning, what is the lowest that this graph goes to? Well, the lowest is going to be the y-coordinate here, okay, of this point, which is going to be y equals 1. So in here, in this case, the minimum is y equals 1, or you could just say 1. This point where the graph bends, okay, we haven't talked about this yet, is the vertex, okay? So this point where it's changing direction, it's going to be either the low point or the high point with these parabolas, we call our vertex. Okay, number 8 and number 9, we're going to be working with this standard form, y equals ax squared plus bx plus c, okay, of a quadratic. And the question here now is, how do we figure out where that vertex is? And we're going to introduce a formula here now, x equals the opposite of b, or negative b, divided by 2 times a. Now remember, when you graph these parabolas, remember how they always have that symmetry, and that line of symmetry, it divides the parabola in half. If you fold over that line, it matches to itself. This axis of symmetry, the formula for that axis of symmetry will be x equals negative b over 2a, and the negative b over 2a will also be the x coordinate of this vertex point right here. So let me show you how that works with number 8. Notice that the a value here is 1, because 1x squared is the same as x squared, so a equals 1. B is equal to 2, see positive 2, and c is equal to 3. So what we're going to do is we're going to do, let's write it up here, a, b, and c. So we have x equals the opposite of b over 2a. So the opposite of b is going to be negative 2 over 2 times 1. So negative 2 over 2 comes out to negative 1. That's the x coordinate of our vertex. It's also the line of symmetry right here, x equals negative 1. Now, how do we find the y coordinate of the vertex? Well, we have to take this negative 1, put it back in for x, and that'll give us our y value. So let's go ahead and do that. We have y equals 1 times negative 1 squared plus 2 times negative 1 plus 3. So this comes out to 1 minus 2 plus 3, which that's 4 minus 2, which is 2. So negative 1, 2 is our vertex. Let's plot that on the graph right here. And now what students like to do to get a good graph is sometimes they'll make a table like this, okay, kind of like a horizontal fashion like this. And what they like to do is put the vertex in the middle. So you see our vertex is negative 1, 2. And then what we're going to do is we're going to pick some points on either side, okay, of this axis of symmetry, like negative 2, negative 3, 0, 1. So all I'm doing is I'm adding 1, subtracting 1, or adding 2, subtracting 2. And the idea is it's going to be the same on both sides of this line. So if I put 0 in, 0 squared is 0, times 1 is 0, plus 2 times 0 is 0. So these all came out to 0, plus 3 more, that's 3. But then I also know that this one on the other side is also 3. If I put 1 in, 1 squared is 1, times 1 is 1, plus 2 times 1 is 2, plus 1 is 3, plus 3 is 6. This one here will also be 6. It's the same on both sides. So let's go ahead and plot that. We've got, let's see, -3, 6, 1, 2, 3, 4, 5, 6. And we've got -1, 2. Let's see, I got that. And -2, 3, which is right there. And 0, 3. And 1, 6. So there we go. We've got our graph. This graph has a minimum. The minimum value is 2. Let's see, what else do we have? The domain is all real numbers. The range, what can y be? Well, y can be 2 or greater. So we would say our range is y is greater than or equal to 2. Domain is all real numbers, we said. And that's it. So you've got a good graph. So now let's jump over to number 9. Same idea. We have y equals ax squared plus bx plus c. Okay, but we need to find that vertex using our formula -b over 2a. Notice the a value is negative. What does that tell us? The parabola is going to open down like that. Okay, so let's go ahead and do this. We've got, this is a here, b here, and c here. Now make sure you capture that sign to the left or in front. So we have the opposite of -8, which is +8, divided by 2 times a, which is 2 times -2. So this becomes 8 over -4, which is -2. So -2, that's the x-coordinate of our vertex. It's also the x equals -2 is our axis of symmetry. And if we want to find the y-coordinate of the vertex, we have to take that -2 and put it back in. Now be careful when you put it back in, you do your order of operations. So -2 times -2 squared minus 8 times -2 plus 1. So that's going to be 4 times -2 is -8. These two negatives give us +16. So we get 8 plus 1, which is 9. So our vertex is going to be, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, right there. Okay, V for vertex. And now I'm going to show you another method here. You can do this table method, okay? But what you can also do is once you find that vertex, you can focus in on the parent function, that y equals ax squared. That gives us the basic shape of the graph, how wide it is or how narrow it is, and whether it opens up or opens down. So I'm just going to make a table on this part right here. Let's do it over here. And let's pick just a couple easy values, -2, -1, 0, 1, 2. And this comes out to -8, -2, 0, -2, and -8. And now what I'm going to do is I'm going to plot from this point. I'm going to pretend like this is our origin. I'm going to go left 2, down 8. Okay, so let's see, that would be right about here. And then the thing is, you can then reflect it over this line of symmetry. So see how I'm 2 units away? If I go 2 units on the other side of the axis of symmetry, I have another point. And -1, -2, so from here I'm going left 1, down 2. And see how I'm 1 unit away? If I go 1 unit on the other side, I have another point. And now we have our graph. Now, another key point that you want to pay attention to is when you're working with either this form or this form, see the c value? The c value is the y-intercept. It's where it crosses the y-axis. So see how this is 1? See how it's crossing right here at 1? So it's an easy point to locate, and then once you know that point, you can then reflect it over the line of symmetry to get another point. Usually you want to have 3 points, ideally 5 points, to get a nice smooth graph. Now this graph has a maximum, right, because it's opening down. It has a high point. It's like top of the hill here. And what is the maximum? Well, it's going to be the y-coordinate of the vertex. It's going to be 9. The range is going to be y is less than or equal to 9. See, it's 9 or below. And the domain, because this graph gradually goes to the left and right forever and ever, the domain is, again, all real numbers. Okay, number 10 and number 11, we're going to talk about the vertex form now. That's this y equals a times the quantity x minus h squared plus k. And the vertex, that point where the graph bends, you know, the maximum or the minimum point, that vertex point is going to be at h comma k. Now where students sometimes get a little bit confused is, see how this is x minus h? So what you want to pay attention to is this number here that's in the parentheses with the x. That number, that h value is going to be the opposite from this sign. So see, this looks like it's -1. It's actually going to be the opposite. It's going to be +1. It's actually x minus, and then h is actually +1. So that's our vertex 1, and then the k value, this is going to be the same sign. So see, this is -2 or -2. It's going to be -2. So just remember, this one is the opposite, and this one here is the same as the sign. Some students that I tutor, their teacher will say, well, this one lies and this one tells the truth. And I find that kind of humorous. But if it helps you remember, that's always good. So let's see. So the vertex here is right 1, down 2. Okay, so that's your vertex. And then here's your line of symmetry, right, that divides the parabola in half. If you fold it over that line, it matches to itself. And now you have a lot of different options. One option is you could say, well, let me just pick some points on either side of this point, okay? Or let me look at the parent function y equals 1/2 x squared. See, I'm basically looking at this y equals ax squared form and graph from here as if it's the origin. A lot of different options. I'm just going to make a table. I think this is a student's most favorite method. Put the vertex in the middle and then pick some points on either side. So I'm going to put 0 and -1 and 2 and 3. So all I'm doing is adding 1 or subtracting 1, adding 2 or subtracting 2. So it's basically the same on both sides. So let's put 0 in. 0 is usually easy to work with. 0 minus 1 is -1. -1 squared is +1. Times 1/2 is 1/2. Minus 2 is -1.5. So that means this one over here is also -1.5. And if we put in, let's say, 3 now, 3 minus 1 is 2, 2 squared is 4, times 1/2 is 2, minus 2 is 0. So that means this one over here will also be 0. It's the same on both sides. So now we can graph. We've got 0, -1.5, which is right here. And I fold it over that line of symmetry. See, it's going to be right there, which is the same as 2, and then comma -1.5. And then we have 3, 0, and again, I can reflect it over that line of symmetry, or -1, 0 right here. And one thing you'll be noticing about this graph is that because of the 1/2, it's a little bit wider, right? So it's opening up wider. And what else? We know that it's opening up because a value is positive. This has a minimum value. That minimum value is going to be at -2. The axis of symmetry is going to be right here through the x-coordinate of the vertex, x equals 1. And the range is going to be y is greater than or equal to -2, and we covered it, right? So let's look at number 11. A little bit different here. See if you can do this one on your own. What's the vertex? What do you think the vertex is of this quadratic? Well, remember this one we said it lies, right? Or it's the opposite, right? The +2 is actually going to shift left 2, and the +1 is the same, so it's going to go +1, up 1. So there's our vertex right there at -2, +1. Here's our axis of symmetry. I just like to draw it as a dashed or dotted line. You won't really see that when you graph the parabola. We're just using it as a guide. Our axis of symmetry is x equals -2, same as the x-coordinate of the vertex. The a value is negative. That tells us the parabola is going to be opening down, right? Negative, like frowning, right? And the 4 is going to stretch it, so that means it's going to be very narrow. But now what we can do is we can use the same table method. I think, again, like I said, this is probably students' favorite way of doing it. Put that vertex in the middle, -2, 1. And let's pick some points on either side. So -3, -4, -1, and 0. So if we put in, let's see, -1, that would be pretty easy. Let's see, -1 plus 2 is 1. 1 squared is 1, times -4 is -4, plus 1 is -3. So that means this one here is also -3, right? They're the same. If we put 0 in, 0 is easy to work with. 0 plus 2 is 2, 2 squared is 4. 4 times -4 is -16, plus 1 is -15. That means this one over here is also -15. These ones are probably going to go way off the graph, so let's just do these ones in the middle. We've got -3, -3, which is right here, and then we have -1, -3, which is right here. So you can see it's opening down, it's narrow, and you've got a pretty good sketch of the graph. Number 12 and number 13, we're going to be working with what's called the intercept form of the equation of a quadratic, okay, of a parabola. And the idea here is with the intercept form is when it's in this form, this factored form, what we can easily identify are the x-intercepts, or what are often referred to as the zeros. Whereas over here in the vertex form, we can easily identify the vertex. In this form here, we can easily identify the y-intercept, right? Because we have the c values, the y-intercept. So each form has kind of like its positives and its negatives, right? But for this one, we can see it's in the factored form. And the way we find those zeros, remember the zeros means where the y value is equal to 0. When y is 0, that means we're right along the x-axis because we're not going up or down. And that gives us those x-intercepts. So what we do is we set y equal to 0. And what you do is you set these factors or these groups equal to 0. So you can make a mini equation, x minus 1 equals 0 and x minus 3 equals 0. add 1 to both sides, add 3 to both sides, and you can see that our zeros, or our x-intercepts, are going to be at 1 and 3. Now, what we can do from here, once we find these x-intercepts, is we can add them together and divide by 2. So 1 plus 3 is 4, divided by 2 is 2. Now, what does that 2 do for us? Well, it gives us the axis of symmetry. Okay, so x equals 2. And because the vertex lies along that axis of symmetry, we know the x-coordinate of the vertex is going to be 2. All we have to do now is put the 2 back in for x to find our y-coordinate of our vertex, and we got it. So let's do that. 2 minus 1 is 1, and 2 minus 3 is negative 1. And so we have 2 times 1 is 2, times negative 1 is negative 2. And so now we've got our vertex here at 2, negative 2. One thing to notice is that, see how this a value is positive? That tells us the graph is opening up. If this was negative, then it would be opening down. Now, what I want to show you here is we were doing the negative b over 2a. That was for the standard form. But here what we're doing is we're doing p plus q divided by 2. So p and q, these are our x-intercepts. If you add those together and divide by 2, that's going to give you the x-coordinate of the vertex and also the axis of symmetry. So now we've got a pretty good graph. If you want to plot some more points, you can, instead of plotting like we did 1, 2, and 3, we could do like 0. That would give you your y-intercept, or you could 4. You can pick some other points to get more on your graph. For number 13 now, notice that this a value is negative, or negative 1, so we know it's going to open down. If we set each of these factors equal to 0, we're going to get x minus 3 equals 0, so x equals 3, and x plus 3 equals 0, so x equals negative 3. So this is where it's going to be crossing the x-axis here at 3 and negative 3. And if we use our p plus q over 2 formula, just like an average, you're adding them together and dividing by 2, that comes out to 3 plus negative 3 is 0, divided by 2 is 0. Okay, so this is our axis of symmetry right here on the y-axis, x equals 0. If we put 0 back in, we get negative 0 minus 3 times 0 plus 3, which is negative 9 times negative is positive 9. So this is going to be 0, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now we have a pretty good sketch of our parabola. It's opening down because a is negative. We've got our vertex here, which was the average of the two x-intercepts. This is a maximum, and the maximum value is 9. And we know the axis of symmetry, x equals 0. We know that the range is going to be below this maximum, so y is less than or equal to 9. The domain is all real numbers, and you got it. So in the comments, put down your favorite method for graphing these quadratics or these parabolas. And if you want to see more examples, follow me over to that video right there where I'll dive into some more examples. I'll see you in the next video.